In the last video, we discussed about transfer function limitations. So here, let's see the differences between this transfer function approach and state variable approach. Here the first point is, transfer function approach is also called as conventional approach or classical approach. And here state variable approach is called modern approach, isn't it? So, and the second point is, this transfer function is applicable to linear time invariant systems. And coming to state variable approach, it is applicable to linear as well as non-linear systems. Yeah, everyone knows that for linear systems, linear time invariant systems means differentiation integral systems. Differential and integral systems are linear time invariant systems. So if you observe, if you want explanation about it clearly, if a system input is x of t and the y of t, and y of t, if it is the system is differential function or integral function, then what happened? So y of t is equals to, if it is differential function, if it is a differential function here, so y of t is equals to d by dt of x of t. So if you apply Laplace transformation, this is y of s, this is s into x of s. If I consider initial conditions are 0, so y of s by f x of s is equals to s. Yeah. So y of s by s of s is nothing but Laplace transformation of output to the Laplace transformation of input is called as transfer function. So the transfer function is there, s. And if it is integral function, y of t is equals to integral x of t. If you consider the function is, the system is integral system, which is x of t, which is y of t. And I can write y of t is equals to x of t. So for integral function, which is dt, if you apply Laplace transformation, y of t is represented with y of s, so x of s by s. So again y of s by x of s is equals to 1 by s, which is also transfer function. So these integral and differential functions are linear time invariant systems. So if you observe all the transfer functions, that is having s or 1 by s. For example, if it is nonlinear, means what? If it is x of t for the system, y of t is equals to x of minus t. Let's assume that. If you apply Laplace transformation, it is x of s, which is y of minus s. So we can't apply, we can take we can take division of these to y of s by x of s, will get a negative sign only. So transfer function is not applicable to time invariant systems. Here minus t, non-linear systems. Isn't it? So time invariant system. Coming to the non-linear system. Non-linear means what? Everyone knows that if x is varying with respect to y linearly, we'll get like this. Non-linear means which is not like this. If you consider a simple equation, y of t is equals to x square of t. So x of t is the input to a system, so which is non-linear system, that is x square of t. This is y of t. So if we consider Laplace transformation, this is x of s and this is x square. Apply Laplace transformation to the x square. So we can write it off x of s into x of s. So I can say that y of s into y of s, x square, that is y of s into y of s. So y of s by x of s is again not possible. So in these two conditions, this is time invariant condition, which is non-linear condition, x square of t. So transfer function is not applicable because which is not applicable for. So by using this condition, I can easily say that it is applicable. It is not applicable to the time invariant and non-linear systems. It is applicable to linear time invariant systems, that is differentiation and integrations. So the second part that is regarding the second point. So it is applicable to the linear time invariant systems. It is applicable to linear as well as the non-linear systems. And second point, and also it is applicable to I forgot to write here, time variant, and also for time variant and time invariant systems. So it is applicable to time variant and time invariant systems. Coming to the third point, which is very important, transfer function approach is limited to single input, single output systems. And here in state variable approach, it is valid for single input, single output as well as the multi-input, multi-output systems. So that's why whenever using multi-input, multi-output systems, so we'll get inputs, outputs and the function in terms of matrices. Whenever there is a multi-input, multi-output system, we will consider matrices, right? And fourth point, in this method initial conditions are neglected. Yes, we know that transfer function initial conditions are neglected. So here we are considered in state variable approach, initial conditions are considered. Coming to the fifth point, it is basically a frequency domain approach. Yes, transfer function is Laplace transformation of output to the Laplace transformation of input with all initial conditions are 0. Means Laplace transformation when I apply Laplace transformation to a system, to a function, to a variable, it comes under whenever Laplace transformation is used to convert the time domain to frequency domain. So the transfer function is frequency domain approach. And coming to the state variable approach, it is a time domain approach. So state variable approach is completely on time domain approach. And the next point is, it is based on trial and error procedures. Transfer function approach is basically trial and error procedure. It is not based on trial and error procedure. For simple example for trial and error procedure, assume we are assuming some points and whether the for example, if we consider root locus, we assume some testing points and we'll check whether this testing point on the root locus or not. So trial and error procedures, basically this transfer function approach. And coming to here, state variable approach, it is not based on trial and error procedure, right? And the seventh point is, this transfer function approach, only input, output and error signals are considered important. So the major important things in transfer function are input, output and error signals. So they are considered as important signals or important things. So the input in transfer function, the input and output variables must be measurable. So it must be in a measurable form. Coming to the state variable approach, state variables need not represent physical variables. So state variables need not represent physical variables. So physical variables are not required to represent. So definitely they need not be measurable or observable, right? That is one of the advantage in state variable approach. And coming to the last point, transfer function of the system is unique and state variable or state model of a system is not unique. These are the major differences between transfer function and state variable approach. So we can say that we can easily identify the advantages after completion of these differences. And what are they? We can apply for both nonlinear and as well as the time varying systems, and also we can apply for multi-input, multi-output systems, and we can consider initial conditions, and no need to represent physical variables. These are all advantages in state variable approach or state space analysis method, right? Thank you.